All right, you guys, let's have some fun, some meteorological fun. It is a snow day across North Texas, and we're gonna do a little experiment that you can do in the pleasure of your own home. All right, first off, I have to tell you the atmosphere is governed by something called the ideal gas law. Translation, well, it means when the temperatures are warm, the air is light, and it's less dense, and then when the air is super cold, it's really dense. So what we're hoping is going to happen with a balloon full of warm air, as we walk outside into the frigid air, the balloon should actually contract. And the reason why is because the atmosphere is heavy with that cold, dense Arctic air, and it should press against the balloon and actually cause it to shrink. So let's try this. It's about 70, 71 degrees here in the building. Let's head outside to a snow-covered parking lot where temperatures are around 20 degrees. I'm not exactly sure how long this is going to take, but eventually we should see this balloon begin to contract as the cold, dense Arctic air begins to push against it. It already feels like it's getting smaller. Now, I'm not exactly sure how small this balloon is going to get. But over time, again, the cold, dense air will begin to squish the balloon down. And then you should be able to take the balloon back inside into where the temperatures are 70 plus, and you should be able to see the balloon once again swell back up. All right, you guys, so after being outside in 20-degree weather for about 5 to 8 minutes, look how much the balloon has deflated already. You can see how it has deformed quite a bit here, again, as the Arctic air continues to press against the surface of the balloon. So the warm air inside being compressed by the cold air on the outside. Remember, cold air far more denser than the warm air. That is the reason why when these Arctic fronts come through, a lot of times you have thunderstorms develop out ahead of the front. The reason why that cold air pushing along the surface is forcing all that warm, less dense air up into the atmosphere, causing those thunderstorms to develop. So again, look at the deformation of the balloon. Now, what we're gonna do is we're gonna head back inside where the temperatures are 70, 75 degrees inside the building, and we should begin to see this balloon re-inflate to the way it was just a few minutes ago. All right, you guys, we are back inside, literally just walking through the door just 30 seconds ago, and already I'm feeling the balloon re-inflate in my hands. It's happening almost instantaneously. It took a little while for the balloon to deflate as the balloon had to cool down to the outside temperature, where right now it's about 20 degrees in our parking lot. But inside this warm building where the temperatures are in the low to mid 70s, I can actually feel the balloon swelling up in my hands already, and we should be able to see this balloon return almost to its full size here in the next couple of minutes. So a pretty cool experiment that you can do in the comfort of your home on a really cool snowy day. After you build the snowman, of course, head inside and give this a try. It's a really cool experiment as to how our atmosphere works every single day.